Buenos tardes. I'm really grateful to have the opportunity to speak with you guys and share some of the things that I've been doing and thinking about. I hope that I get to learn more from you, from what you might see that you relate to from what I'm talking about, and I hope that you learn from me as well. So this is my name, and this is where I live on the internet. My name is Sally Lehman. That's my dog, Pseudo. And I have a degree in electrical engineering, but my first job out of college was web development, and I found that I really, really enjoyed doing that. So now I have 7 years of SaaS application experience. Things that I really love working on are CI/CD, chat ops, and configuration management. Most recently, I've been doing a bunch of work with MongoDB and Salt. I've been coding on some level for a very long time. When I was a little girl, I did BASIC. In high school, I did some JavaScript. In college, I did a bunch of assembly, and now I'm just doing a lot of configuration management most recently. So this is, as David was saying, this is the company I work for, Auth0. It's a SaaS authentication platform. It's an identity platform. It's really awesome because it has, it's developer focused. It's has a ton of SDKs, a lot of bells and whistles. There's a breach password database that you can check against automatically. There's multi-factor authentication, single sign-on, and social logins. So if you are implementing authentication in your application, this is possibly a good solution for you. So the talk that I'm going to have here is about pets versus cattle, and that metaphor. We're going to get really deep into that. This is Pseudo again, and her friend Coco. And this is a bunch of cattle, and I have no idea where they're from. And so just so we're all on the same level, pets, to the metaphor of pets versus cattle is talking about the nature of servers in an environment. A pet is a server that requires specialized care and feeding. You cry when it's gone. It's really hard to replace. And yeah, you're attached to this thing. With cattle, you're not attached. Its purpose is to scale. It's easy to duplicate and monitor. And you don't cry when they die, usually, unless you really like a cow. So this talk is about the struggle of how to get from pets to cattle. And when I have done this many times, you start to see a pattern of things that you need to do. So I hope to show that process here. So another reason I'm doing this talk is because there's a ton of code or information out there on how to code things. If it's greenfield, there's a ton of stuff. If it's legacy code, there's not as much information on how to refactor and fix existing code. That's not as fun, right? And then legacy configuration management, where it's the system that has accumulated configuration over time and maybe not in the best of ways. There's very, very little information on how to reverse engineer servers. So that's why I am taking a stab at it here, and hopefully it will be useful. So why do we care about legacy configuration management? Why don't we just replace these things that are broken completely and not try to figure out what's there? Well, often that's the right thing. But sometimes these systems make money, and they are making a ton of money, and it's something that is costing huge amounts of resources to keep going in that manner, and maybe it won't in the long term if you don't address it. And it's often, unfortunately, it's very complex, it's very dangerous to, or sometimes it can be very dangerous to change these systems. But there are situations where you maybe want to stabilize the system before you replace it with something that is more predictable. So here I have the outline where I'm defining what legacy configuration management is. I'm selecting a particular definition. There's lots of different ways you could say this. I have 4 more talks in my head about the other situations, of the other maturity levels of what legacy configuration management could be. But here I'm just going to define what it is. Then I'm going to walk you through this process, which is the things that you are generally thinking about in order. It's kind of like a waterfall, but not exactly. Like, these are generally the stages you're in, but you're also popping back up. And specifically within each stage, you're having to iterate and improve before you can move on to the next stage. So here is the definition of legacy configuration management that we're going to go with today. This is the server that was assembled with configuration management 4 years ago, and no one has run it since. This is the server that has a 5 bash scripts and some manual work, and the guy left the company. Or, in fact, in the situations I've been, that happened, but it was 10 servers and 20 servers, and each set was by a different person and different scripts and different. So you end up with 1,000 servers, all with percentages of different custom configuration. And so the drift can be really, really huge when you get at scale. So this talk is specifically at scale, so we're thinking about how do you handle that much drift. It's not just one server, it's a lot. And specifically what I've worked on are, I've worked on multiple things, but database structures. This can happen. I've seen this happen more than once, where it just gets left because developers don't want to mess with the database, and so what ends up is the system starts to decay in that manner. So when I have entered these situations, I have to think about the questions that we're going to answer to actually solve the problem. And the first problem is, how do I model the existing structure accurately, because I have so much drift. And the image here is just showing, if you're familiar with the pets metaphor, I'm just trying to see what's going on there. And the next question that I want to ask is, how do I structure this? How do I create a replacement that is going to accurately replicate the processes that the existing production infrastructure is already doing? And this can be a problem if, say, the test environment for that system is not there or is decayed. I had a situation where I was coming into a new environment, and I say, hey, where's the test servers? Oh, this team repurposed them for something else completely. So it's either I make the test servers or I'm direct to production. So the final thing is, how do I replace these servers with something, or how do I replace these safely? If there's lots of inputs and outputs, how do I make sure that I am able to fail over or connect in a way that you don't end up with downtime? Because if you have this huge, expensive, brittle thing, usually downtime is something that the company really, really doesn't want. So that's another thing you have to think about. I was involved on a project where it was a guy who built up this huge new replacement for the existing system, which was pretty brittle and old. And it was a great design to see it, like he was solving all the problems that the old system had, but the project never actually got off the ground because they had never thought about how do I transition this old brittle, how do I decouple this system so that I can actually implement this new thing. So if you don't think about that, you're dead in the water. So now we're starting to get into the process. So this is the very first thing that you do, and it's a picture of the Westminster. What you see here, I'm trying to, it's the Westminster Dog Show that you're seeing here, and you pretend you are this lady and you're judging the dogs. These guys are your, the pet owners are your application, the people who have owned the application up to the point that you are there at least on some level, or they're the people that you're interacting with or your application has to interact with. And as I look back on the projects that I've done, even though you may have worked on similar projects, you generally save everyone's time if you go up and say, hey, what are your bugs? What are the locations of your code and your documentation? What's quirky about this system? And you do that up front, and it allows you to start this feedback loop. It's a really good way to start to establish rapport with people too, because you're able to, have them tell you things. And so you start this feedback loop, and the next thing you do is start bookmarking and mapping and quick referencing. Go to where they said stuff was, and from there you'll start to make more connections. And your goal here is to start your lists and notes and build on that feedback loop where what you really want is a quick reference. So when you actually are looking and implementing, you're able to go back here and get this up to date. You kind of know what was expected. You'll probably find that it is not what is there, but it gives you this really good base. So I'll have a couple demos on what I'm talking about here. So one of those things where you have a huge amount of servers and a huge amount of drift is I can't take any one of those servers and have it expect that that's going to really represent what's going on the rest of the system. So I need to look at everything. I need to look at all of the servers. I need to look at them often and fast. So I need some sort of tooling to be able to do that. So if you do have a system where it is you do have something representative, one tool that's really good is called, unfortunately it's no longer supported, but it's called Blueprint by DevStructure, and it gives you a ton of different facts about the system, your processes, your services, and just allows you to compile all this information, even translates that into what is probably out of date, but configuration management code like Ansible and Puppet and stuff. So that's pretty awesome. But what I'm gonna show you is over a larger amount of servers. So the next thing that you do once you have deployed a discovery tool is to actually create a development environment based on all the research that you've done so far, and this is allowing you to play and start moving. So now your feedback loop is complete. I'll hit the first demo here. Okay, so Salt is one of my favorite tools because although it does require that you install a minion, this is 90 different servers that I spun up on DigitalOcean to just kind of show you some times and just show you how things work. So, oh dear, I bet you can't see the bottom here. Ah, good. Okay, so here I'm just seeing what the system is like, and it only takes 1.5 seconds to look at all 90 servers. Pretty sweet. Sorry? 90. There's 90 VMs here. So they all iterated through and looked, and so it gave me a report for all of that. And now I am speaking my bad Spanish into a pink gorilla text note directory and just creating some drift here. So I put the pink gorilla, which I used the wrong Spanish for, and then 10 different servers, I'm going to have a green gorilla. And the other nice thing about Salt is it is a configuration management language, so I am using the same tool that I'm ultimately going to use to create my configuration management. So here's the power of Salt that's really nice for these huge amounts of systems or larger numbers of VMs. I'm going to do a diff on those so that I can see what's different. So I see that most of my servers have the pink gorilla, but then 10 have green. So then you run into these files and structures that are really long. Some configuration files are hundreds of lines long, and this is not going to work because you're going to have screen roll. So now what I'm doing here is just a little hash. So the power here is you're able to compile all these results because it's easy to run, some command that SSH in, but it's another thing to have that all in a nice readable format that you can work with. So there you can see, it's not all the way up there, but it's the hash of one of those. So I'm going to show one other, or actually two other demos here. So this is Ansible. And what's nice about Ansible is that you don't actually have to install anything on a server. So if you're in a corporate environment where you have to get permission to install things and it's just really hard to get there, then this might be something to start with. And it is also a configuration management tool with its own pros and cons. Don't worry, I don't have those up anymore, so it's fine. So what I was trying to say is the Ansible takes longer. I think it might be due to the Python. We're on 90 servers, but now it takes 12 seconds to look something up instead of 1. So if you end up with 1,000 servers and it takes a minute to do any sort of lookup, then you have to know what all your lookups are beforehand to have any sort of stuff, or any sort of speed in doing this, that just slows you down. This is mostly read-only, and this is not something that you want to do normally in an environment. You want to have tests and structure so that you don't cause problems. But when you have a system where your deployment is broken and things are brittle to the point where you can't really function, then you have to get out. How do you get out? This is one way you can do that. So I'm just doing the same things I was doing on the Salt Stack, but with the Ansible syntax. I'm putting 10 different, putting my green gorillas in here. So unfortunately, Ansible is not, it does have modules where you can do that diff stuff that you can do with Salt, but it's not quite as straightforward. So one of the nice complements to Ansible is parallel SSH. And parallel SSH is almost as fast as Ansible is, or almost as fast as Salt is. Obviously, it's not a configuration management tool. But I can do the same stuff where I'm putting that file in. Okay. And yeah, so this is, I actually won't have time to go all the way through this, but parallel SSH does have nice formatting, the way that Salt did, where it is compiling the different servers and with the ones that have similar information on them.
Am I even close? I can't see where the cursor is. Am I there? No, I'm not there. Shoot. Okay.
I would like to re-enter, but I need to get back into the talk here. Okay. Are we there? Now you see what my notes are. There we go. Thank goodness. And it didn't start from the beginning. Wonderful. So here's the Ansible demo. We did that. So next, we want to mitigate the risk of change. And these are your pets, your dangerous pets, and they have muzzles on them. So you want to put muzzles on your pets because when you start making changes to a brittle system, you want it's better to just think, yeah, I'm probably going to break things. I mean, obviously you're going to put in place things to prevent that, but you got to, if you don't have that mind, the important thing is there's so many different pieces that if you don't keep forward motion, you're never going to get to the end of this. So you mitigate the risk of change, and the reason you're mitigating the risk of change in order to be able to recover and to give yourself the confidence to be able to push forward and make the changes you need to do. And part of that is version control and backups. So backups with the database, make sure that you can restore them somewhere. Don't just make sure you have, or that they're running, but they have data in them and that you can restore. And version control, make sure everything has version control. And I've been on systems where you expect that this is the case, but then I find that a database isn't actually being backed up, and it's one of the main databases for the application, or the version control for the deployment structures is completely on one server and there's no version control anywhere. So this happens. So as you start to build up your development environment, you'll run into this stuff, and you need to make sure that you have, and if it's not a database and it's application, then you want if you're going to make changes, you want to make changes to or have some way to fail over to something that doesn't have those changes, so that you're not causing problems. And next, you want to mitigate the risk of change with monitoring and testing. So the picture here, I think of monitoring and testing as a leash on your pet, so you know where it's going and you can keep some control on it. So this is another thing where all these things are not you're not implementing these things to last 10 years. You're doing it so you can get configuration management in place and you can start implementing production level good stuff. So maybe you get smoke tests in there, maybe you get Datadog in there, and set up basic tests to ensure that stuff is actually working. One nice tool for when you're comparing your configuration management language against or making changes is server spec. That's one way to test your configuration management whether the changes you're making there are actually happening in the way that you want them to. So now we want to create a deployment system. So hopefully this is maybe the only thing that you actually use your powerful discovery tools to actually maybe implement, and hopefully everything else you're actually using a real deployment process. You want to design, this is a super critical point where if your deployment structure is not efficient, you will have a very hard time doing anything. So this is where you do need to spend some time. This is a picture of cattle, where a cattle mover somewhere in the Midwest, and something that's because cattle naturally move in semicircles, and they get scared when they see a human at the end of the ramp. So this actually allows them to move faster. And the panels that you saw, it wasn't all see-through there. Well, if they see things out of the corner of their eyes, that's another thing that makes them balk. So if you have one cattle sitting there, he's clogging up the rest of the system. So this is a good metaphor for both your human processes and your deployment processes, is when you have situations where it's something that is, you're able to get over it, but if you have to get over something 1,000 times, that really, really slows things down. So you want to look for ways in your deployment process and when you're rolling things out to be as empathetic as you can, because that's going to pay off in exponential ways in the end, because when you do have to roll things out, you're going to have to roll them out a lot. So now we are finally deploying to production. And we haven't talked about code up till this point, like actually writing the code, except for the development environment. And up to this point, it's been more of a playground. And now you have your structures, you know what's there and generally what you want, and you want to keep that momentum. So when you start to write code, you want to start with the smallest component that you can. If it maybe it's just a service component, maybe it's a server, maybe you're lucky and it's smaller than that, or maybe you're not as lucky. But your goal is to start with something that you can move with fair speed through your entire pipeline, and you're going to do that over and over again and start to gain confidence so you can handle the larger pieces of the system. One thing is, when you don't have automation in a lot of different pieces, this cycle is an opportunity on each cycle to improve your system and get to an automated fashion. So if you have a manual process, maybe you can get that to a list of commands. If you have a list of commands, maybe you can get to a script. If you have a script, maybe you can get to an automation to orchestration. So if you can hop those little bits, each of those are going to give you that extra time that you need and extra oomph for the stuff that's harder. So now this guy, this is the situation that I came upon where someone said, yeah, we have things in configuration management, but we just use it to build the server. Well, as soon as they built the server, probably maybe a day later, it's no longer it's not enforcing state, and thus you're not really using configuration management properly. However, if you have a system that is very brittle and you can't necessarily fail over to all new stuff, sometimes this allows you to get really granular about the things you can change. So you can go per resource on a configuration management tool and go out and see what the diff is between different servers and change things and sort of ensure state that way. So this is one method of deployment to production that you can use in that iterative process that I was talking about. The other reason this is bad is because you're doing something on top of what's there. You cannot be sure that what you're doing is actually it's not exactly what should be, or so you can't replace things from scratch just from doing this necessarily. There could be some roadblocks along the way. So if you do have the ability to fail over a whole service and put them on new VMs, then that's what you want to do. That's by far ideal. And you don't necessarily have to fail over the whole functionality. Maybe there's a way for you to segment that and do the iteration. And this is what everything is built up to. And so from here, if you can scale your stuff up from scratch, then you can start implementing things in the ways that we are actually told to do in actual more robust structures, because you are just able to get things through faster. So some of the pieces that I've talked about here about improving your automation level of automation and maturity of your configuration management has been things that we have done at Auth0. We used to have so our entire infrastructure used to take one person 3 weeks to replicate in another region or for a different customer or whatever. And through that iteration process of making pieces more efficient, we now can do that in 3 days, and anybody on the infrastructure team can do it. And probably by June, we can do that in under a day. So in summary, this is the process that you can dig yourself out of sticky situations with. And I hope that you are able to learn from my pain, and so you have less pain. And here are the people that I have talked to in regards to this talk, and really have contributed ideas and structures, and I really appreciate that. Here are some of the sources that I had. Thanks so much for listening. That's it.